Hello everyone. Today let's solve the problem fight against the traffic. Right? So you can completely read the problem statement along with they have mentioned input and output as well with the examples. In example, they have given input and output and the desired output for that input. Right? So I'll just summarize the problem for you so that we'll be able to understand easily, and let's discuss the approach along with the implementation. So just give me a second. So what the problem says? So the problem says that the town NSK has n junctions. They have the name of the town is NSK, and it has n junctions and m roads. N junctions and m roads. Also, what is our main goal? Our main goal is to build one new road without reducing the distance between the mayor's home and the mayor's work. We have to build new road. For this one, I'll just give NR. So new road. We have to build one new road between the mayor's home, that is S, and mayor's work, that is T. So one new road between S and T. So that's what we have to build, one new road between S and T, mayor's home and mayor's workplace. So we need to find the number of pairs of junctions where a road can be built such that the shortest path between S and T is unaffected. The shortest path between S and T, this one. Shortest path. We have to find the shortest path distance first. So shortest path distance has to be unaffected. Also, what we need to find? We need to find the number of pair of junctions where a road can be built, right? So that's what we need to find. So number of pair of junctions we need to find, and also we need to calculate the shortest path distance, right? This is what the question says. So I'll just delete this one. Let's discuss the approach. I hope the problem statement is clear. Let's discuss the approach. So what we can do, first step is, as usual, we'll be going with the input reading or the input handling. So first step is always input reading or input handling. So while writing the code, you'll come to know about this. So if you have followed the previous problems, you'll be knowing. So input reading is same, almost same for all the problems. So first step is always input handling. So after the input reading or the input handling, so we'll be going with the BFS to calculate the shortest path distance. So we'll be going with the breadth first search. So this is the approach that we'll be going to calculate the shortest paths. So why we will be making use of the BFS? We will be using BFS from S and T to compute the shortest distance from these junctions to all the other junctions. So let me write this. We'll be making use of the BFS. Mainly how we will be using, we will be seeing that one in the while we write the code. Basically, we'll just know, we should just know by now that we'll be making use of the BFS from S and T to compute the shortest distances. Right. After computing the shortest distance, as usual, in the question they have mentioned, we have to calculate the potential, this one, pairs, right? Yeah, we have to calculate the pairs. So pair of junctions. So what we will do, for each pair of junctions, suppose if we have the pair of junctions, for each pair of junctions U and V, what will that aren't directly connected, we will check if building a road between them does not shorten the path between S and T. We'll just check building a road does not shorten the path between S and T for each junction U and V. That's what we'll be doing here. So we'll be checking for the potential pairs. I'll just write CPP, check potential pairs. So this will be the third step. So after the third step, what we'll be doing? We'll be writing the condition for not shortening the path. We shouldn't shorten the path, right? While calculating the distance, while building a road between mayor's, this one, home and workplace, we shouldn't shorten the path. They have clearly mentioned in the question. So we will write the condition for not shortening the path. So here this is condition for not shortening the path, NSP I'll write. We'll write the condition for not shortening the path. Nothing but we are ensuring that after adding the road between U and V, the distance between S and T remain at least the same as before. Not, it shouldn't. It should be either same or it should be more than that, right? So we'll ensure that one. In the step 4, we'll be writing the condition for writing the condition such that the condition it will not short on the path. So that's what we'll be writing for. Then after the 4th condition, we'll go for nothing but we will output the result. Nothing but we have to display the result, right? We'll be making use of Node.js or the JavaScript. As we are making use of the JavaScript, we'll be making use of the console log and we'll be displaying the result. I'll just give output the result. So this will be the 5th step. So this is the approach that we are going for in this particular problem. So main thing you have to keep in mind that for calculating the shortest path, we'll be making use of the BFS. So just keep in mind this one, and let's start writing the code so that we will understand this one better. So just let me remove this one. Just give me a second. Just give me a second. So yeah, let's start writing the code. Initially, let's import the file system to read the input. So I'll just give require of fs. So why this extra braces? So yeah, next we have to read the input. We will split by new lines. Why? We have to read the individual lines of the input, right? So for that reason, we'll be splitting the input. Also to distinguish between the distinct elements in the same line, we'll be making use of this one, trim. Trim. We'll be making use of trim. Also to remove the white spaces as well. So how can we write that? Const, I'll just give input equals, I'll just make use of read file sync. Read file sync of start from the 0 and we'll set the encoding to UTF-8. Then let's make use of the trim to remove the spaces or white spaces. Then to read individual lines, let's make use of the split. I'll just make use of the regular expression. So this will be /n/r. Let's close the braces. Also, let's slash this. So after this one, reading the input, let's initialize the counter for reading the input lines. We have to read the individual lines, right? First, we have to start with the first line. So let's initialize the count to read the line to 0 initially. So next, let's write the function to read and return the fast array of integers from the input. Let's make use of the custom read num, this one, function. So here, this will be count plus plus. So I can just make use of split. This is one thing. Also map of a. This will be plus a. This is one thing. Next, what we will do? We'll be, as we discussed in the approach, we'll be going with the this one, breadth first search. Nothing but BFS function to calculate the distance from the start node. Nothing but we are calculating the shortest path, right? So for that, I'll just make use of function BFS graph start and end. These are the parameters that I'll be considering. So here, let me give let distance equals. Let's initialize the array. New array of n+1, size n+1, nothing but, and we will fill this one with positive infinity. So just make sure that you are giving capital I. This is, and also we are filling with positive infinity, not the negative infinity. So we are initializing the distances as infinity initially. Also, let's initialize the queue with the start node. So I'll just write queue equals within the array start. We are initializing the queue with start node. along with this, let's initialize the distance to start node. That is nothing but initially 0. We can write in this case, this one start within the array. This one, we can just initialize this one to 0. This is where. Next, after the initialization, as usual, we'll be going with iteration. Nothing but BFS loop to traverse the graph. So I'll just make use of the while loop so that this condition remains true. So this will be length of the cube should be always greater than 0. So I'll just make use of the while loop. I'll just set that one. Set this one. Let u equals q dot shift. This is one thing. So we are dequeuing node u here in this step. After this, we will explore all the neighbors of node u. Again, nothing but we'll be making use of for loop again. So I'll just give here v of graph u. U and v are the distances that we have took, right? So here, if the neighbor hasn't been visited, I mean infinity distance, then we'll be processing it. Nothing but we'll be making use of the condition. Writing condition is easy. Here u and v are the distances that we have took. So if the distance v is infinity, we can just set the distance to neighbor. And also after setting the distance to the neighbor, we will add the neighbor to queue. Nothing but to add, we'll be making use of the push. We can make use of the built-in push, right, in the JavaScript. So this is easy. I can just write distance of v if this is equal to infinity, right? So we'll just give infinity. We have to set the distance to neighbor. Nothing but distance of v. We'll set this one to neighbor. Neighbor is nothing but distance of u. Distance of u plus 1. After setting the distance to neighbor, we have to add the neighbor to queue. So for adding, let's make use of push. So this will be push of v. So this is fine. So this works absolutely fine. So next, we will return the distance that we have found. Nothing but we are returning the distance array, right? In simple terms, let's give distance. So this is fine. Next, let's write the main function. Main function, why we are writing the main function? To solve the problem, right? Mainly this one, the main core logic of the function. So core logic we'll be writing inside the main function. So we have written the BFS function to calculate the shortest path. Next, let's write the main function. So I'll just come here, function main I'll give. Within this, we have to read the number of junctions, n, roads, m, and special junctions, s and t. Nothing but mayor's, the distance between the mayor's home and mayor's workplace, right? So how can we write that? We can individually write and assign the read num, as we have to read the number of junctions as well as roads and the special junctions s and t. Nothing but we have to read n, m, s and t. Instead, I'll just make use of the destructuring operator. I can just write n, m, s, t. Let me assign this one to read num here. Yeah. So after this, let's create an adjacency list for the graph. So creating adjacency list is easy. I'll just give graph equals, let's initialize the array to n plus 1. Also fill this one with initially null, and let's map this one. Let's assign this one to empty array. So now let's read and build the graph from the input roads. We have initialized in the previous step. So next step will be going with the iteration, or will read and build the graph from the input roads. So I'll just give for I equals 0, I less than m. Let me increment this one. So here again I'll be making use of the this one destructuring operator, because we have to read the endpoints of each road, right? So we are distance, we have took the variables u and v. So again we have to read u and v. So for that purpose, I'll just give u, v, and let me make use of read num here. This is fine. Next, we will add u to v's adjacency list, and also we'll add u to v's we'll add v to u's adjacent list, and vice versa. we'll add u to v's adjacent list, v to u's adjacent list, and u to v's adjacent list. Nothing but bidirectional, right? So this is simple. I'll just give graph of u dash. We have to add, right? For adding, I'll just directly make use of the push built-in method. So here, let me give graph of v a push of, this one will be u. This is fine. Next, let's get the shortest distances from junction S using the BFS. So we will get the shortest distance from S as well as from junction S and T using BFS. So how can we write that? These two lines, these are two distinct things, right? So distance from S I'll give, this is BFS of graph S and N. These are the parameters that we have took in the BFS, right? Also, we have to get the shortest distance from junction T as well, along with S using BFS. And this one, I'll just copy the same thing and make the necessary changes. Let me copy the same thing. Here, I'll just make this one distance from T this time. This will remain same. Graph, instead of S, I'll just give here T. So, this is fine. Next, the shortest distance between S and T we have to calculate. How can we calculate? Let distance T, I can just give distance from S. So here within the array we have given. So let me initialize the count to 0 initially. So we are initializing the counter for valid junction pairs. So after initialization, next let's go with the iteration. Nothing but we will iterate through all the pairs of junction. Junction what? U and V, the distance, where U has to be less than V. This we have to keep in mind. The only thing we have to keep in mind that we are iterating through all the pairs of junction U and V. We know this one. But the main condition is U has to be less than V, because we'll make sure that the shortest path, there shouldn't exist the shortest path while we are building the road. That's what the question says, right? So let's start the iteration. This will be, we'll start with 1, U less than or equal to N. Let's increment the U. Also, let V equals U plus 1, V less than or equal to N, V plus plus. Oh, what did I miss here? Sorry. Just give me a second. But we'll make some changes. So yeah, this has to be for loop, right? After this, we will check if U and V are not directly connected by the road. So this is, so you can just check whether graph of U that includes V, this is equal to undefined, or I can write in this way or as well. If not of graph of U, we can directly make use of the includes built-in method. So this will be V. So yeah, this is fine. Next, we'll check if adding a road between U and V maintains the distance between S and T properly. So for that, we can just make use of the if condition again. So here I'll just come if of distance from U and T we have to take, right? I'll just take this one, distance from S. This has to be U plus 1. Also, let's concatenate this one, distance from V, it has to be, right? So let me give this one, distance from T, of V. This has to be greater than or equal to dist. I'll just give dist ST, and also just give me a second. Let me again copy the same thing and make the necessary changes until here. I copy this one and let me paste it over here. This one has to be, this one has to be S of V this time. This remains same. This T of U this time, vice versa, right? It is greater than or equal to of ST. This remains same, and if it is, then within this we will be incrementing the count. So I'll just give count plus plus, nothing but we are incrementing the valid pair count. We have to determine the valid pairs itself, right? So for that reason, I'll just increment the valid pair count. Finally, what we will do, we will output the final result. So final count of the valid pairs. To display the output, I'll just be making use of the console log. I'll just come here. Let me make use of console log of valid pairs. So we have took this one in the count here, right? So count, we have initialized to count, right? So count of valid pairs we are getting in the count. So I'll just write count to this. Let me call the main function over here outside. So this is fine. This is it. Let's check with the input whether this works or not. This has to give the output 0, right? Let's check. So here, what problem we have? Assignment to the constant variable. So 6, count, right? So line number 6, I'll come here. Let read num count. So yeah, I'll just change this one to let. Again, cannot read properties of undefined reading split. So just give me a second. I'll check. So what I have done here is I have given equals minus. I don't know when did I give minus. This is fine. Let me click on read again. So here while qname.length, qname is not defined. This is not qname actually. Just give me a second. This has to be q.length, right? Wait. This has to be q.length. This is fine. Let me hit the run again. Reference error, q is not defined. I have defined q, right? This has to be q. So many typos. From distant reference error, dist st is not defined. The line number 47. Let's come here. Line number 47. Let's see. Distance st. Oh, here. This. Just give me a second. So this has to be distance st. Here I missed. Let me run this one again. So now we are getting the output 0, right? Some typos basically. It's fine. So let's check with this input. This has to give the output 5. Let's check with this. So now we are getting the output 5. This works correctly, right? Let's check with the last input. This has to give the output 3. So let me hit the run. So this works absolutely correct, right? So this works absolutely correct. So just give me a second. So let me copy this one and let me come here, click on submit code. So the problem A, right? So A, fight against traffic. I'll just paste this one and click on submit. So wait for some time. Let's wait for some time. So why this is so slow? So let me reload this once. So yeah, you can see this accepted, but still, yeah, you can see here the code got accepted, right? So this code works absolutely correct. So yep, I had just done the some of the typos actually here. I don't know this one q and q dot length. This took something else. Had type q itself. So while it showed suggestions, I think I hit the enter. So I should have seen that one. So some of the typos here. So now the code works absolutely correct. And this is it. Thanks for watching, guys.